This third film on the TCP IP protocol stack will introduce the private IP addresses. But first we have to look into the history, and in the early days of the internet, they defined three so-called address classes, actually 5, D and E, but A, B, C was for regular users. So the A-class networks were if you had really large networks. So they were for networks with up to 16 or nearly 17 million hosts or devices on the network. Class B was if you had about 65,000 addresses, and Class C if you only had up to 254 different devices in the network. So I guess HVL would need to have a Class B network with up to 65,000 devices in our networks. But this class system is not in use very much anymore. But still, in order to avoid the exhaustion of addresses due to the few addresses available in IP version 4, they introduced something called private IP addresses. So they had three address groups, one in class A, one in class B, and one in class C, which are private. So if you have the public network, that is the big internet, you have unique addresses on every server and every router in that big internet, and you still have. Then you can have something called a NAT router or a NAT server, and inside that NAT server you have another addressing system for the devices inside the NAT router or the NAT server. So that is the private network for the company or for a private home or for the airport or whatever. But this is for our LAN. So let's use HVL as an example. We have a NAT server, and inside we have all the addresses that we use at HVL, and the same at my home. Then on the outside you have the public networks with the public addresses. Now inside the private networks you can use addresses that are not unique worldwide. So let's study this address here, 10.1.1.2. That address is definitely used by many computers worldwide, but inside a private network it will appear only once. So you will only see it once inside a private network. But when you see this NAT server here, on the inside it uses the 10 domain. So all the devices on the inside has the 10 domain, while on the outside it has 200. And if you study the list here, the 10 is one of the private addresses, the group from 10.0.0.0 to 10.255.255.255. So these addresses here are among those private addresses, while 200 is not in this list. So 200 is not a private IP address. Private IP addresses are not unique worldwide, but unique inside a LAN. On the other hand, the public addresses, like this one, 200.1.1 and 170.1.0.0, they are unique worldwide. So public network addresses, they are unique worldwide. Private network addresses can be reused in other networks. So if I, for example, had a Class C network, my address is, for example, 192.168.215. Well, that's not unique worldwide, but inside my network it's unique. So the NAT server standing here, it's a so-called network address translation. So it's a host that sits here and acts as an agent between the public network and the private network here. And it will translate if I have a message from this computer to this server here. Well, when the packet from my computer enters the NAT router, it will transmit the packet onto the public network, but with a new unique address. So let's see how that's done. The NAT server can operate in 3 ways, and the definitely most common one is the single address NAT. But let's just look at the 2 others. Static NATs means that for each device inside a private network with non-unique addresses, it translates to a new address which is unique. So for each device inside, it needs to have a bank of addresses. So if you have, in this case, 3 devices on the inside, it needs to hold 3 addresses. The only reason to do that is the same thing that the proxy server does to make the devices on the inside anonymous. A dynamic NAT is saves more addresses by saying that, okay, I will have a bank of addresses, but I will only have a limited amount of addresses for public use. So if I have, for example, 3 public addresses, only 3 devices from the inside can communicate at any time. Then the most common one, the single address NAT, is that the device here on the public side, it only has 1 address, and in this case it's 213.18.123.100. So all the messages that comes from the inside via the NAT and wants to go to the outside has that address, 213.18.123 and 100 in this case. But it also has some extra information added to it, 101, 102, 103, and that's hidden as a TCP port number. So it has a unique port number associated with that special address for each device on the inside. So if this device wants to send a message, it goes out with this unique address, but it's unique for my entire network on the inside. And then the port number, it's is how you can see that it's for that specific device in the network.